Welcome everyone.
Hi, Ms. Smith.
Hello, Ms. Smith.
Today we are going to continue our work with scatter plots, and then look at how to create a least squares regression line to help us find the answer to a real-world problem. Here is the investigation that we will be working on. We will use a least squares regression line to help us determine the amount that Joe can expect to sell his truck for. You have all had a chance to look at the scatter plot of truck mileage and selling price in your small groups. Enter your estimated price into the Google Doc for the class to see. Adam and Brian, why don't you come up and share with the class what you came up with?
Looking at the highest price values at every mileage value, it seems like Joe should be able to sell his truck for about $20,000.
Thank you, Brian. Thank you, Adam. Kathy and Tama, can you please come to share what you found with the class?
We used the points furthest to the left and furthest to the right to figure out what the trend looked like. And our conclusion is that Joe can get around $15,000 for his truck.
Thank you, Kathy and Tama. Alex and Aisha, can you please come up and share with the class?
Yes, Miss Smith, we thought that the way the points were going in the scatter plot, it looked like the price of the truck would be a little under $10,000.
Very good, thank you, Aisha. Thank you, Alex. Looking at the Google Doc, you can see that there is a wide range of values that you all concluded, ranging from $10,000 up to $20,000. When we use a line to represent a set of points, we call that a regression line. A regression line will help you to be able to arrive at a better estimate. Use your dynamic software to insert a line that represents all of the points in the scatter plot. You have a few minutes to work in your small groups on this. When you are ready, please enter your new result in the Google Doc.
If we have the line go through just the highest points, it will be too far away from most of the other points.
I agree. Let's move it a little lower.
Wow! When you put a regression line on it, it looks like we were way off on our estimate the first time.
Tama, let's keep our line going through the endpoints. This way some of the points will be on the line.
That sounds right. And look, our answer comes out to about $13,100, which is pretty close to our original estimate of $15,000.
I think we should have the same number of points above and below the line. What do you think, Aisha?
I think instead that the line should be as close to as many points as possible.
That's good, Aisha. If the same number of points is on either side of the line, it could be horizontal or even vertical, which would not be correct for these points. Here is the formal definition of a regression line. The formal definition is: a regression line is a line that describes how a response variable y changes as an explanatory variable x changes. There is also another related definition about the standard equation of a regression line. A regression line relating y to x has an equation of the form y hat equals a plus bx. Now let's take a look at the results from each of the small groups. Everybody's estimates changed, but there is less variance. That's good. Share with the class how you feel about the new estimates your regression line is giving you.
It's not easy to find a line that represents all the points. But we like our new estimate better than our first one.
Our new estimate is much higher, but the line looks like it is in a good place.
We like our line. But Ms. Smith, they still don't agree. Shouldn't there be a way to get a consistent estimate for how much Joe's truck can sell for?
How? We already placed the lines. How can we know how to do it any better?
Those are great questions. Let's take a look at it. There is a mathematical way to position the regression line so that we get the best fit for the set of points. That involves a concept called residuals. A residual is the difference between an observed value of the response variable and the value predicted by the regression line. Residuals can be positive or negative depending on whether the point is above or below the regression line. You can see on this graph that the points above the line are the positive residuals and the points below the line are the negative residuals. The red lines show the vertical distance from the line to each point.
So if we make the red lines on the graph as short as possible, then that would be a good regression line.
Since some are negative and some are positive, will they cancel each other out?
Actually, they always will. But if we square the values, they are all positive. This is represented by squares along the regression line. Using your dynamic software and your regression line, add the squares to the graph and notice what happens when you adjust your line.
The squares grow and shrink.
That is correct. If the squares are made as small as possible, then you have the best fit regression line. It's called the least squares regression line.
We have found our least squares regression line using the dynamic software, and it gives us a value of $11,105. So Joe should be able to sell his truck for this amount.
Very good. Let's look at what all of the groups have in the Google Doc. We can see that everyone came up with the same result, $11,105. Do you think this is a reasonable answer?
It does seem like a reasonable price for Joe's truck.
Yes. In our first estimate, we were trying to make sense of the set of data points, and each group had a different view of how to interpret it, giving a big variance in our answers.
And in our second estimate we used a line to summarize the data points, and that helped us get to a better answer. There was still a variance, but it was smaller.
Then in the third estimate we actually calculated the placement of the regression line. Well, the computer did the calculations for us using the least squares.
And we all agree that this is the best answer.
So does that mean that $11,105 is the only acceptable value?
Because there is some variance with most of the points that went into calculating the least squares regression line, it makes sense that there could be some variance in the answer.
Joe could sell it for a little more or a little less, and it would still be fair.
Nice work, everyone. This was a good discussion.